Greetings from K.S.Rangasamy College of Technology. This is S. Muthukumar, Associate Professor from Department of Mathematics. In this video, I am going to explain about the skewness. What is meant by skewness? Skewness is a measure of symmetry in the distribution of a data set about its mean. If a data set is perfectly distributed like normal curve, then the skewness is 0. In this case, the measure of central tendency values median, mean and mode are almost equal. If the distribution is stretched more on one side, either right side or left side, then it is a skewed distribution. It is classified into two categories. That is, one is if the tail is longer on left side about its mean, then it is a negatively skewed distribution. The other case is positive skewness. If the tail is longer on right side about its mean, then it is a positive skewness. This skewness can be evaluated by using different formulas, Bowley's and Correlation coefficient of skewness. These calculations are explained in the example. Calculate coefficient of skewness for the data given below by Correlation and Bowley's method. First, I am explaining the calculation of skewness by Bowley's method. This is the individual data. First, rearrange the given values in ascending order. And there are 9 terms. So, capital N equal to 9. Skewness by Bowley's method. Formula is SKB equal to Q1 plus Q3 minus 2 median whole divided by Q3 minus Q1, where Q1 is the first quartile value. It is evaluated by using the formula size of n plus 1 divided by 4th item. That means size of 2.5th item. So 2.5th items. That means average of second and third items. So Q1 is the first quartile value is the 21.5. Then median. This median of individual frequency is evaluated by using the formula size of n plus 1 divided by 2th item. That means size of 5th item. Here the 5th item is 25. So median is 25. Similarly, we can calculate the third quartile value Q3. Its respective formula is size of 3 of n plus 1 divided by 4th item. That means 7.5th item. 7.5th item means average of 7 and 8th item. So its average is 26. Then the skewness by Bowley's method is minus 0.5. It is negative answer. So it shows the given distribution is skewed negatively. The same skewness is calculated by Pearson method. Here the Pearson formula is x bar minus Ez divided by sigma. X bar is the mean of the given distribution, Z is the mode, and sigma is the standard deviations. These are evaluated by using these formulas. X bar equal to sum of x divided by n. So mean value is 24.7. Mode, it is denoted by Az and defined by most frequent value. Here 25 repeats 3 times in the frequency. So mode for the given data set is 25, and the sigma, that means standard deviation, is calculated by using the formula square root of sum of x square divided by n minus mean square value. Therefore, the sigma is 6.338. Then the skewness by Pearson method value is minus 0.035. So this is the example for calculating skewness by Pearson and Bowley's method for discrete frequency. Here the given problem is distributed for discrete frequency. For discrete frequency, we have to find out the cumulative frequency to find out the Q1, Q3 and median values. Q1 equal to size of n plus 1 divided by 4th item. That means size of 9.25th item. So it comes under this 10. So its corresponding x is the Q1 value. So Q1 equal to 10. Then median is size of n plus 1 divided by 2th item. Size of 18.5th item. So 18.5 comes under the value 24. So median is 15. Similarly, we can find out the Q3 value. That means size of 27.75th item. That means Q3 equal to 20. So after calculating Q1, Q3 and median, apply these values in the Bowley's formula. So which gives the value as 0. That means by Bowley's method, its skewness value is 0. There is no skewness for the given distributions. This value may be varied for another method. The same problem is explained for Pearson method. Here x bar for discrete case is sum of fx divided by n. So multiply this f and x to get the value of sum of fx. Then x bar equal to 15.694. Mode is the most frequent value. That means 15 appears 14 times in the distributions. So highest frequency. So its corresponding x is the mode. So mode value is 15. Then standard deviation formula is square root of sum of fx square divided by n minus x bar square. For this problem, standard deviation value is 6.363. So using these values in the Pearson formula, we can get the value of skewness by Pearson method. Here the value is 0.109. So the same calculation for continuous case is explained here. Calculate the coefficient of skewness from the data given below by Pearson and Bowley's method. The calculation of different values for continuous case is given here. The first one is x bar mean value. It is evaluated by the formula sum of f into m. M means midpoint of the each class interval divided by capital N, total frequency. So find out the f into m value. This m is the midpoint. That means 5 into 525, 15 into 690, like this. So its total is 6605. So x bar equal to 46.84. Next to find out the model class. So for that, first we have to identify the model class interval. That means class with highest frequency. Here the highest frequency is 35. So its mode value lies between 40 and 50. So using this interval, we can find the mode value. So mode formula for continuous case is Z equal to L plus F1 minus F0 divided by 2 times of f1 minus f0 minus f1 into I. I means class interval. So using this model class interval, we can identify these values. So L is the lowest frequency of model class interval. This means 40. This is L. L equal to 40. Its corresponding frequency is F1. Its previous value is F0. Its subsequent value is F2. So, and the class interval is 10. This difference between highest and lowest value. So using all these values in the mode formula, the mode value is 47.37. Then find out the standard deviation value. Standard deviation formula for discrete continuous case is sum of fm square divided by n minus sum of fm divided by n whole square. That is x bar square, mean square value. After substituting these values in this formula, the sigma's value is 16.98. Here we have evaluated the mean value, mode value and standard deviation value. Use these values in the Pearson formula, x bar minus z whole divided by sigma. So its skewness value is minus 0.031. This is also negatively skewed distributions. So the same skewness by Bowley's method is explained here. For that we need the value of quartile deviation values Q1, Q2, that is median, and Q3. For continuous case, Q1 class interval is obtained by using the formula of size of n by 4th item. That means size of 35.25 item. So it lies in this interval 30 to 40. Its Q1 formula is L plus n by 4 minus PCF. That means preceding cumulative frequency. For Q1 interval, PCF is 22. Q1 class interval is 30 to 40. So then 30 is the lowest value L. Its corresponding frequency is F. Class interval is 10. So after substituting all these values in the Q1 formula, the Q1 value becomes 36.30. Then find out the median class, and using this median class find out the median value. Median class interval is 40 to 50. So its corresponding F value 35. Then its previous preceding value is 43. Its lowest value is 40. So its Q2 equal to 47.85. Similarly, find the third quartile value. Here the third quartile value is 59.25. So use all these quartile values in this Bowley's formula. Q1 plus Q3 minus 2 times of median whole divided by Q3 minus Q1. The Bowley's coefficient of skewness is minus 0.006. So here also we got the value as negative. That means negatively skewed distributions. So these are the methods to find out the skewness by different methods. Bowley's method and Pearson method for the different cases, individual, discrete frequency and continuous frequencies. Some problems are given here. So try to solve these problems for both the methods.